Hi friends, welcome to our channel. Let's look at today's daily challenge problem. So minimum operations to make binary array element equal to 1. So this is the first of such question. So in this video, we are going to use linear scan to do the problem. Actually, I can also put an extension. So here, you can also solve this problem using exclusive all. In other words, this operation. But here we are going to content ourselves with the linear scan. That will be sufficient, I guess, for this problem. So here we are given a binary array. So we want to check if we can use the below operations to make all the element 1, right? So here the operation is called flipping. So we're flipping 3 consecutive numbers. So flipping means change 0 to 1 and 1 to 0. So we want to return the minimum number of operations required to make all elements in nums equal to 1. Otherwise, we are going to return -1. So for example 1, actually you can see the explanation as output will be 3. Well, for the example 2, it's impossible, because if you want to do this, you need to first make the first position to be 1. So in other words, you need to flip. But then this one will be, these 2 ones will be 0, 0. And then you do flip again. So then this one will be not able to make it 1. So that's the example 2. So now the constraints are the following. So the length can be as long as 10 to the power 5. So this basically means that we need to think of term complexity. So with that said, actually we can see the hint. This hint is actually very important, because here if num 0, the leftmost one is 0. So then we must do flip operations if we can, right? So that's actually the exact point. So here, after changing this one to be 1, then use the same logic on the remaining array. So our linear scan method will follow this one, right? So actually, as long as you can encode this 2 hints into your coding, then you will get valid solutions. So here, let's look at the coding. First, I'm going to get the length of nums. So then I'm going to set a result to be 0. So notice that I reset this. Initialize this result to be 0, not -1. Because if it's not, we are going to return -1, I will directly return it. So this is the one important point. And then I'm going to initialize the pointer to be 0. And then, well, I is less than n, then we can do the logic. First, if the left sides are all 1s, so we just keep shifting to the right, right? So, well, I is less than n. This is to make sure I is in bound. And then we can call this expression, right? Nums I. Otherwise, you cannot call this expression. So if this equals 1, so we're going to do I plus equals 1. So after this while loop, there are 2 possibilities. First is that I is greater than or equal to n, or this guy going to be 0, right? So if I is greater than or equal to n, this means we arrive at the end, so we directly return the result. We don't need further increment that. So otherwise, so we are going to consider the different cases. So because each flip, we must have the I corresponding to 0, but for each flip operation, so we need at least 3 elements. Therefore, we need this one. So the current index. So here, let me do this. So the current index is at I. The ending index is n-1. So we need the length of this subsequence to be at least 3. So in other words, n-1 minus I plus 1 is greater than or equal to 3. So this is the requirement. If this number, so this number will be n minus I, right? So if n-1, I'm going to keep like this, because this is more interpretable, right? If this is less than 3, so we cannot finish like in example 2. So we're going to return -1. That's why when I do the coding at the very beginning, I'm not initializing result to be -1, but 0, right? Here is the logic. If we cannot finish that, we have already returned. So then we are going to change the 3 numbers. So actually we don't need to change nums I. If you like, you can, because this is 1 minus nums I. So similarly, we can do nums I plus 1 equals 1 minus nums I plus 1. Similarly for 2, let me copy this down and then do this. I plus 2 and I plus 2. So the reason is that we are going to do I plus 1, and then the result is also incremented by 1, right? So this essentially we can pre-assume. I will just change that to be the opposite, right? So then we can do the return the result. So this will be a full solution. Let me first do a test. Yeah, it passes the 2 test cases. Now let's look at the generic case. Yeah, it passes all the generic cases. As I mentioned, this line is optional, so you can just make it a null. Let's submit. Yeah, and another thing is that because here we are going to use 3 consecutive ones. We write this one and this one, or you can just use a for loop, right? So for CJ in range I plus 1 up to I plus 3, then you can do nums j equals 1 minus nums j. So afterwards, you still do I plus 1 and the result plus 1. So this will also be good. Let's submit that. Yeah. So with that said, that's basically about it for the current video. So as I mentioned at the very beginning, you can think of this extension. So you can encode the 3 consecutive numbers using exclusive OR to see if you can solve this problem. So with that said, I guess that's it for the current video. Thank you for watching.